While we're on the topic of while we're on the topic of circular motion, I wanted to talk about artificial gravity and some theories on how we might create it for space travel. So if you imagine a space station here, there's no like up or down in space, so we have to kind of throw ourselves against the wall in order to feel a weight. If you remember, we talked about the difference between like what we mean by weight in terms of everyday jargon and technical physics vocabulary. I mentioned that we feel weightless, like when we're on a roller coaster and we get to the top. Our bodies want to keep going in a straight line, so we kind of leave our seats. And when we no longer feel our seat, that's what causes our feeling of weightlessness. We've lost that normal force acting on us. So we can simulate having a weight by just creating a normal force on ourselves. So if you imagine that we have a space station here, if we rotate that space station fast enough, our own inertia would carry us into the wall, and it'd be kind of like the rotor ride again. If you remember, in the rotor ride, I said the normal force was equal to the centripetal force, and the faster we go, the more we press into the wall. And so what we get here is we wouldn't want to use v squared over r. We'd want to use a, because we're trying to get a to equal ag. And basically we are trying to set these two equal to each other. So we want to be able to go a certain speed at that radius away. So if we are like a kilometer from the center, we can figure out how fast we need to go in order to feel the same weight that we normally do, where g is 9.8. So that's one of the ideas. Things get complicated because of moment of inertia and the practicality of the designs. For example, where all the mass is in the space station kind of matters for how hard it is to rotate, among other things. But I just wanted to talk about how artificial gravity would work. Basically, if we get spinning fast enough for that particular radius away, we should be able to feel like we would on Earth. And that's it.